so. And what I'll probably do is I'll probably post this to YouTube and then go viral, more or less. Okay, we are actively recording. So now if you say something out loud, it will live on YouTube forever. So keep that in mind. And we're at 28 people, which is really good because that means that only one person has not attended. Okay, so this is today's lecture. And hopefully, if we have enough time, we'll get to a little bit about Python coding and the way that we're going to interact in specifically Jupyter notebooks for the majority of today's lecture, but also for the majority of the class as we go forward. I keep forgetting I can't hit next. Okay, a little bit of background about myself. So I, as you can tell by my current location, am currently the head of solution at a startup called CB4 Analytics. We are a machine learning company that works with brick and mortar retail organizations to send recommendations to store managers about particular product behavior. So for instance, we might work with a merchandising team to optimize promotions for products on the floor. We might work with operations teams to find issues or chronic out-of-stock problems with respect to their, the products that are coming from their vendors. Maybe they're Pepsi Cola or Frito-Lay. We're also working with some fashion and bookseller retailers. So for instance, one of our customers is Barnes & Noble. So maybe we'd be working with publishers like Random House. Random House is not sending enough books to certain locations. How do we optimize the routing of those books in order to optimize the most possible sales? So as the head of solution, I work more or less in the data science field. On my day-to-day, I'm not necessarily always doing data science. A lot of times I'm having customer meetings. I'm acting as a business analyst to gather requirements. I'm working with different IT partners to implement a data science model in a in our ProductionWise app. And that's sort of what I'm doing on a day-to-day basis today at CB4. I've been in my current role for about 2 years now, and I currently go to New York City every other week, but I'll always be in Syracuse on Mondays for class. In terms of my background, I also have been working as a professional in the space for about 8 years now. 4 of those were spent at Morgan Stanley, which is a large financial bank, and specifically I worked there as an analyst on a recommendation platform for financial advisors. It was a great experience for me. It was what introduced me to a lot of the common machine learning and recommender systems. And it was really formidable in the sense that I got to work with some really experienced people right out of school. So it really benefited my career. And then after that, I kind of got sick of working in a really large company. So ever since then, I've been working for startups. So I'm currently on my second startup. And the first one was with another company called ChatID. And I worked as the senior data analyst on a chat platform, which was posted on retail websites. So as you can see, retail is sort of where I'm living these days, but I'm mostly interested in optimizing workflows. I'm really interested in things concerning optimal performance. Staffing models are really important to me, trying to figure out how to optimally assign people to do particular types of work. And I do have a background, specifically a master's in statistics and operations research, where a lot of that is driven. In terms of the types of work that I've been doing, I've held most roles in an IT capacity. I've been a product manager, business analyst, data scientist. I've never been a true software engineer. It's not really something that I've delved too deeply into. I don't know necessarily that my coding best practices are up to the standard of a software engineer, but certainly up to the standards of maybe a data scientist. And in terms of data pipelines and this course material, I was really excited when given the opportunity to teach this course. This is my first semester teaching IST652, and I've been getting kind of caught up on the material for the last 2 months and really excited about what we're going to kind of do this semester, focusing on using Python for building data pipelines, cleaning data and massaging it to do what we want, engineering solutions. And it's really where I think it gets me out of bed in the morning. It's really exciting stuff. And then lastly, my undergraduate degree is in mathematics and philosophy, so hopefully I don't talk too abstractly or ethically about too many of the problems we're trying to solve. So that's a little bit about me. Does anybody have any questions about the course, expectations, the way that the class may or may not be run? Okay. Silence on the platform. It's going to be a fast lecture if no one asks questions. But maybe that's what you want. Okay. Next up, what is scripting for data analysis? So since this class is IST652, scripting for data analysis, what the heck is that, right? Many of you might not necessarily know what it means to analyze data or what it means to write a script for that matter. So I sort of broke it down into different aspects and then aggregated it all together, same way that I would sort of approach a data set. So scripting, what is scripting? Scripting is essentially coding instructions to be executed by a computer. More or less, it's programming an executable function. For this class, we're going to be using the general purpose language Python to do all of our script execution. But what is data, right? Data are values of encoded information used for either transmission. So you want to send information from A to B, or you want to determine what is the nature of A and B. So it's either for transmission or for analysis. Those are really purposes of data. And then lastly, I should say though that people do tend in the modern day to collect data and then never do anything with it. For me, I think if a tree falls in the woods and you don't hear it, did it make a sound? If you collect data and you didn't analyze it, does it have a purpose? So I would argue no, but I think that that's yet to be seen. Perhaps when the computers overthrow us as humankind, they'll have a use for all of that archived data that we never got around to. And then what is analysis? So we have our notions of scripting and data, but what is analysis? And for me, and these are all my personal definitions, analysis is the leveraging of information in order to draw conclusions about the world. So you want to determine, I don't know, think of something off the top of my head, what is the attendance rate of this class, right? We have 27 out of 28 students attending, so our attendance rate is probably somewhere around 95%. Could be more. My statistics or my ratios on the top of my head are not great. And then lastly, bringing it all together, what does it mean for scripting for data analysis? And this is sort of my definition. There may be one that is opposite that in the actual guidebook for IST652, but for me, it's writing script which a computer executes for the purposes of analyzing data so that we, as analysts, can learn more about the world. That is what it means to do scripting for data analysis. Any questions about what the whole point of this course is? More or less, this is what we're going to be doing all semester, writing scripts for a computer to learn more about the world. All right, crickets. Nobody is asking any questions. Okay, not a problem. I haven't lost anybody. I still have 28 participants on the line, which is great. Okay, why should you ask yourself, oh, hold on, I have a question. This is great. Is there data cleansing in this process? Absolutely. Data cleansing is a huge part of this process. And in fact, the decisions about what data to keep, cleanse, or throw out can ultimately really affect, especially in a data science pipeline, can really affect the results and can really skew results often. So yes, data cleansing will definitely be part of this workflow. Any follow-up questions? Okay. All right, so why should you, ask yourself, take this class? It is not a required course, nor is it a prerequisite to subsequent courses. Why should you take this course? Do you want to be a software engineer, data scientist, business manager, business analyst, data analyst, or a DBA? And for those of you that do not know, a DBA is a database administrator. Does anybody want to be these things? Maybe, maybe not. How about these things? Oh, how about these things? Do you want to be an artist? Do you want to be a laborer? How about a salesperson? You can be a stay-at-home parent. You can be a business owner. You can be a customer service representative. We have one person that specifically does not want to be a DBA. Good to know. Thank you, Daniel. All of these things, I can guarantee you, I could find a use for scripting for data analysis for them. if it's an artist, maybe they want to better understand the common prices for similar art on Christie's, and they want to do it in an algorithmic way. A laborer wants to better understand their healthcare insurance, and they can find a way to access the government database to choose the best plan for Obamacare, for instance. Or a salesperson wants to better understand the market trends for the things that he's selling. All of these different little ideas that a person might have, this is an opportunity to analyze data. And for me, the best way to do common and current data analysis is using a tool like Python. I'm not against using R. I think R is also a great tool. And even for those of you that have access to something a little bit heavier like SAS, I think all of these tools ultimately accomplish the same goal of reproducibility and I guess production quality access to large data sets, but also automating that process to reproduce results and accumulate and process large amounts of data, where it would be almost impossible to do either by hand or certainly on a single machine. Okay, so job prospects. So for those of you that may or may not have wanted to be a DBA and any of the other roles, last night I queried Indeed.com to see how many open jobs were created in the last 30 days for each one of these roles. So if you're curious about whether any of these had, I guess, a potential, I can tell you that being a business manager, there are almost 34,000 jobs that were open in the last 30 days. There were 2,300 data scientist jobs that were posted in New York. I'm sorry, I should state that these are all in New York City alone. So in New York City, there were 2,300 data scientist positions that were opened in the last 30 days. And I can attest, driving back and forth to Syracuse to New York City is taxing, but not impossible. So if you are interested in staying near campus, but also working in New York, consider it possible, but not ideal. So definitely all of these roles have a ton of possibility. And I think that understanding what it means to analyze data and script using a language like Python is definitely a win for your resume and a win for the way that you can approach problems algorithmically. Why else should we take this class, right? So I designed this very, in my opinion, very pretty graph. And for me, it sort of describes an analytics lifecycle. So starting at the top node, we have this idea of identifying a situation. So maybe it's a question. Maybe it's a broken process. Maybe it's a problem. Maybe it's simply just a curiosity. What you can do with this new information is you can acquire data about the scenario, about the situation. Once you've acquired that data, you would want to take it and format it. Once you've formatted it and cleaned it, you want to analyze it. Once you've learned something about it, you can now draw inference. You can actually say, like, yes, this problem that I identified has a solution. Once you have a solution in hand, you can enact change. And now that you've enacted a change, you've utterly changed the situation that you were in before. But now that you've changed the landscape that you're operating in, you now have a new opportunity to identify different situations under different criteria for which you would either need to acquire new data or acquire the same data in a new time period to run an additional analysis. So for me, analytics is one of the best jobs in the world because you are never done answering questions. There will always be more questions to answer because every time you enact a change, you've changed the variables. Unlike a science experiment where you have certain things that are steady state, certain things that are variable, and then you want to kind of control and test the hypotheses. In real world conditions, everything is changing all the time. So you're constantly given new opportunities and new scenarios to analyze and evaluate. And especially in today's modern, let's call it a data science paradigm or data science ecosystem, things like recommender apps or machine learning algorithms are constantly taking in new data and tuning themselves, tuning the models to improve over time. And those are the types of opportunities where a lot of the information that we're going to learn in this course will really kind of come alive for you. Now, by no means is this a straight data science class. I think that there are going to be far more sophisticated classes that are available from the iSchool that will teach you different machine learning models. But this class is really going to be powerful in the sense that you're going to have a great foundation for approaching data science problems. Now, both algorithmically, both from a scripting point of view, the ability to leverage Python to solve problems, but also conceptually. How do I conceptualize a problem? How do I better understand the different, I guess, pain points for an organization? Or how do I understand what are the driving factors for a particular issue? And you can only do that by acquiring data, formatting it, cleaning it, and analyzing it. And that's really what the foundation for this coursework is. If you interview if you interview most modern data scientists, they'll tell you that probably 85% of their work is acquiring, cleaning, and I guess taking summary statistics or descriptive statistics of data sets. And more or less, that's what we're going to be focusing on. So if you're part of the data science track, you're going to get to learn 85% of the things you'll ever need to know in this class, which for me is very powerful. Obviously, I think the 15% is probably ultimately more important and more influential in their workflow, but this is the foundation of how you can leverage those types of things. And for those of you that are not on a data science track, rest assured, this is not a data science class. This, again, this is scripting for data analysis. And if you are simply, if you never need to go further than descriptive statistics, this is still a great place to do that. And I think that ultimately most of what the modern analyst does is more or less answering counts, sums, and ratios. I think those are probably the most common answers that an organization ever needs to know. Any questions up until now?
Yeah, I actually had a quick question about the difference between an analytics person and a data scientist, because like you kind of put both in your query. I was also curious how you also create all that data as well.
Certainly. So someone that works in analytics usually is more involved in answering business questions. I think the problem here is that data science, as it exists in the workforce, is a very ambiguous thing, and it can kind of run anywhere from someone that's very good in data visualization, someone that's very good in data engineering, and there's an entire spectrum between those two things where a data scientist can live. For me, and someone that works in analytics or just an analyst is someone that does not apply statistics or machine learning or, I don't know, more or less, if they're not applying machine learning models, they're probably not a data scientist. I think a data scientist goes an extra step further to better understand advanced statistics and modern machine learning and I don't know, machine learning algorithms, I would say. But it's a very blurry line. You could have a data scientist that is more or less right out of school and they don't really know a lot about the different data sets, and they just have a company that hired them as a data scientist. Whether or not they are truly a data scientist, I don't know. Then you might have a PhD student that generates or creates new algorithms that are put into the corpus of the data science, I don't know, ether. That person is definitely a data scientist, but they may not know very much about, let's say, Python or scripting or applying particular model types. And then in terms of how do I query that data, very naively, I simply typed in the titles of those different roles and then looked at how many results were yielded in the last 30 days using the advanced filter function in Indeed. Did that answer your question, Alan?
Yes.
Okay.
Yep, I got it.
Great. If you are still confused, that's perfectly fine, mostly because it is a very confusing space to be in, especially if you're looking for a role in data science. You can often interchange a lot of different search terms or queries to get to the same result. Daniel asks, what type of data will we be analyzing, and do we have to find our own data for analysis? So, excellent question, Daniel. We will get to a little bit later in the slideshow, specifically the different types of data we will be analyzing, and there are three categories of data. And yes, there will be a final project for which you will be responsible for finding your own data set. But in the requirements for the final, I've already listed some good places to start. Does that answer your question? Okay. Great. Okay. Oh, hold on. I have a new comment. Yes, very good. All right. So starting off at a sort of a high level, what is a data pipeline? This is an important concept because it sort of takes the end-to-end process of what we're going to be working on in this class and putting it in the framework of the modern business. Data pipelines are very, very common things that people implement. And specifically, a data pipeline is software which eliminates manual steps from a process and enables smooth automated flow of data from one place to the next. So whether it's an ETL process that takes data from one database to another, it's an example of a data pipeline. Maybe it's a web scraping tool that goes to a website, pulls data down, formats it, cleans it, throws some of the data out, and then loads it to a database. And then that database maybe feeds into a visualization tool. So that's another example of a data pipeline. How do you implement one, right? So first, you need to understand the business logic that goes into the current workflow. So define what, where, and how data is collected by sort of converting existing business logic into algorithmic steps. So for those of you that are maybe less familiar with the term algorithm, I've used it a few times today in lecture already, but for me, an algorithm is really just a set of dependent ordered instructions or processes. So for instance, an algorithm might be make a pot of coffee. To make a pot of coffee, you need to take water, you need to take coffee grounds, and you need to take a filter, put the grounds in the filter, put the filter in the coffee pot, add the water to the coffee pot, and hit start. That might be an example of a very naive coffee making algorithm. But then algorithms can become more advanced. So maybe the algorithm accounts for two types of beans, right? Maybe you have ground beans or whole beans. So then the algorithm says, go acquire coffee. If coffee is whole bean, then take out grinder. Add beans to grinder, get ground beans. If not whole bean, then you have ground coffee, and then you can skip this entire section. This is an example of an algorithm. And specifically, when we implement a lot of the different cleaning mechanisms or data ingestion or data processing steps, they're going to be done algorithmically. Another reason why, or another instance of how you would implement one is automating a process involved in extracting, transforming, combining, validating, and loading data for further analysis. So often a pipeline is taking over a manual intervention. So what's very common is you might, at work, as a non-data person, be asked to generate a report. Maybe it's from a system, maybe you do it in Excel, and you do it manually. You do it a couple of times, and then you realize that you keep getting asked over and over to produce the same report. So a very common use case is to take manual data processing and automate it. You simply create a process that will take the data from one place, massage it, format it, and save it to a new location. But why does any of that matter? It matters because if you're doing it manually, and specifically depending on the business that you're working in, if you're doing it manually, you may be error prone. You may be a bottleneck to other decisions or other processes downstream, or there might be latency. There might be problems with doing it locally because the data set's way too big and it's taking up all of the RAM or all of the processing power in your computer. You can't do anything else. It totally locks you down. So in order to kind of combat those three things, errors, bottlenecks, and latency, we can actually create processes that run either automatically overnight, so use the computer when it's not being used for other processes during the day, or you can send it and put it on a server, and the server has all the processing power you need, and you can just have it run without human intervention. And in fact, a lot of sophisticated pipelines can even process multiple data streams at once using different priority queues. You know that process A is process B is dependent on process A, so you make sure you do process A before B, or maybe A and B are independent, but A is more important to get done sooner, so you deprioritize B, and you do A first, and then you do B. So you can create sort of complex rules about what gets done in what particular order. But most importantly, it's a necessity for today's modern data-driven enterprises for data pipelining to exist. There isn't a business out there that lives in the technical age that doesn't have at least some level of data pipelines, whether it's outsourced through some sort of automation tool or CRM platform, or if they have a Syracuse graduate coming in as an intern or something else where they have created data pipelines for them. Any questions about what a data pipeline is? Okay, questions? All right, so I created a case study. It's a loose term, but I created an example of what it means to create a data pipeline. And I did this by registering my house on Airbnb. Now, it was a little extreme, and my wife was not very happy with me because she doesn't want me to actually put my house on Airbnb. But nevertheless, I want us all to think about Airbnb for a moment. For anyone that doesn't know what Airbnb is, it is an international online property rental business. Another company that would be a competitor would be one called Vrbo, VRBO. And for any international students, I don't know if there are other companies maybe in China or in India that do something similar. If there are, please post them in the chat. I'd be interested to learn more about them. But for the case study that we're going to look at today is how can Airbnb estimate the amount that a property may earn, right? How can they possibly come up with a reasonable estimate or recommendation that you should put your property down on the market for? So this is sort of the investigation that we're going to do. So if you remember the process chain, you have at the top was a business scenario or something that you wanted to solve. So the first step, if you all remember, is acquiring data. So specifically, this is the first screen that after I began registering my home for the purposes of this case study, I got a little estimate here that says for 1 month in Manlius, which is again this town that I live in, if I put my house up for Airbnb rental, I can expect to make about $1,000 a month, which I think is outrageously. I don't think I'll ever make that, even if it was on the market, but that's their estimate. So my question is, how did they get to that number? What's the pipeline that drew them to this recommendation value? So let's consider a couple of, we call them WH questions, but more or less it's who, what, when, where, and how. So the who. Who is using Airbnb, right? Where are they getting this data from? And specifically, what are their demographies? What is their geography, and what is the motivation for them using it? Like, who is using it? Why are they renting homes on Airbnb? What is the purpose of using this tool? Next up, the what, right? What properties are available? Either what types, where are they located, and other, I guess, values about a property. How many rooms are available? What are the different nuances that one might consider when considering a property in a location that's not their home? So for instance, maybe we're looking at different types of properties like apartments, condos, guest house, or even just a simple room. Then you have when, right? When are people looking for rentals? And again, all of these questions are helping to frame or design the answer to the question that we're looking for, right? How does it come up with a reasonable answer? And so when are people looking for rentals? Are they looking during the summer, the winter? I don't know anybody that would want to stay in Syracuse in the winter, but maybe they do. Maybe they're coming from an even colder place like Alaska. Are they looking for rentals on the weekdays or the weekends? When am I available to rent my house out? During the weeks, weekends, the weekdays. Where are the travelers coming from, right? Is this their final destination, or is this just a path between New York City and, let's say, Montreal? This is a convenient stop. Maybe this is a great place for people that want to go see Syracuse basketball play. That my house is a reasonable accommodation for people from out of town. Or maybe during the New York State Fair, people want to stay and go to the fair. This is a great opportunity for them in the summertime. So how? So how can this estimate be influenced? This is another great question. What are the different variables that can influence the value? Is it, are there different festivals that go on? Are there different things that are going on with respect to the location and time frame that I'm available to rent that can influence the estimate value? All right. So once you sort of kind of frame your approach to the problem, the next step is sort of writing a series of business rules. So the focus here is what data needs to be collected, right? How do we source data in order to solve this problem? Now, obviously, Airbnb is already collecting a ton of data, and they probably set up their platform long before they came up with estimates or recommendations for I guess rental properties. They probably didn't. They just allowed you to put whatever price you wanted before coming up with adequate market conditions. But nevertheless, where are we collecting this data from? How do we present this data? What's the format? Is it structured, unstructured? Is it in a database? What are the privacy settings around this data, right? What's the level of granularity? Or do we need to know the specific user, their name, where they live? Do we need to know that level of information, or can we aggregate it? Or can we mask it or disambiguate it such that you don't know my name, you only know my unique ID? You don't need to know anything about my PII or personally identifiable information. You simply need to learn a little bit more about the type of user that I am. That's very common on social media platforms or other recommendation platforms. You just sort of need to know my persona or my cohort. Next up, what action will this be driving, right? So we're collecting all this data. Like what are we trying to influence? So if they make a recommendation to me for a specific price to set my home on, what action is that meant to do? Am I meant to take that and implement it? Is that meant to sort of drive particular types of behavior? So better understanding not only the scenario, but what is the influencing factors? How do we actually change the scenario or the landscape that we're analyzing? So the deliverable in sort of this business rules phase are clarifying functional requirements by either describing the final deliverable or, in this case, sort of designing a mock-up. So what I've done here is this is sort of a rudimentary version of what property listings would look like on Airbnb's website, but then I highlighted some different data gathering areas. So specifically, you might consider dates or the number of guests or the home types or price. All of these are different mechanisms that Airbnb will use to gather data for somebody that's interested in the local manliest market for homes. Oh, sorry, I lost my presentation. There it goes. Okay, so modeling a data pipeline. So now that we know the question, we want to try to better understand how we take this data, clean it, combine it, analyze it, and then ultimately use it in some meaningful way. So here, the focus is, what is the source of this data? And for me, the two simplest ones are, what are the active properties that already exist in the proximity of my home? And what are the active requests for similar properties in this space? So again, since Airbnb is a marketplace, think of this as more or less, you have the available properties for rent, and you have the, I don't know, let's call them the vacationers interested in renting properties. So it's the collision of the two marketplaces or market forces coming together. So you'll notice that each phase I've implemented, let's call it a Python process. So the first one is leveraging SQL. Now, I'm not saying that necessarily the data has to live in a SQL environment, but let's assume, for instance, that active properties and active requests both live in structured data formats. So they live in databases. Just so that you all know, there is no requirement that you are familiar with databases, database design, or even database querying like SQL, but it is definitely a tool to have in the arsenal of the analyst or data scientist, especially when acquiring data. So the first stage here is extracting and combining these two data sets from active properties and active requests to learn a little bit more about the local demand and supply patterns for properties in manliest New York. The next thing that we want to do is we want to construct and format an appropriately analyzable piece of information or data set. So specifically, we're going to be working in this class with a lot of different data analysis tools, specifically in Python. And for me, one that's really powerful is both NumPy and Pandas. And those two combined, we'll see later in the semester, will allow us to do interesting things and manipulate data in really powerful ways so that we can more easily analyze. So now that we have the data in an analyzable format, the next thing that we want to do is clean it. So we want to clean it and decide what we want to keep versus what we want to toss. So by toss, I mean maybe there's some data that's so irreconcilable or doesn't match the expected data format, or we realize represents some piece of information that is not relevant to our analysis. So for instance, maybe we want to understand better, again, how much my home should be listed for on Airbnb. So we've queried a bunch of information from active properties, and that includes things like, I don't know, mansions. I don't live in a mansion, so for me, we can toss that because I don't think it'll influence the result of our analysis in a positive outcome. So for me, it becomes an irrelevant piece of information that I don't want to impact anything downstream. So I will remove it or toss it. Next up, we have this idea of analyzing and recommending. So this is where we're going to apply either descriptive statistics, so we can just learn about the average or the mean, the median, the mode, the distribution of prices, and the success of those among active requests on the platform. So using all of that information, we can make meaningful decisions and recommendations to an end user, which brings us to the last step. So in Airbnb's case, once you've analyzed and made a specific recommendation, how do you get that back to the user? And in this case, we would use Python to render it in-app, probably using something like a Python web framework or some other server-side interaction among JavaScript and Python. Now, if anyone is feeling utterly overwhelmed by this, rest assured, we will learn everything from the ground up in this class, starting with a little bit of Python today, specifically, hopefully, if we can get to it, strings and numbers. So we're going to start all the way at the ground floor and then work our way up to something along the lines of this data pipeline. Any questions about pipelining, some of the ideas that I talked about so far? Happy to answer questions that might come up.
For the web client, is that going to be something like a Django framework that we may be using at the end?
It very well could be. It can also be, so to be honest with you, we probably won't do any web client interfacing in this course. Now, certainly I would like to say that for anyone that is interested in going above and beyond the material in this class, I will not hold you back, and I highly promote it. If there's something about Python that you're interested in learning, as long as you're still learning the core material in this course, you can go as far as you'd like to go. So for instance, if you're interested in developing a Django framework-based website, then go nuts. If you're interested in leveraging something called TK Inter, which is building a small app on your local machine, not maybe deploying it to a server for other people to use, that's great too. Or if you really just want to write some scripts that analyze data, that's perfectly fine, and that's really the expectation of this course. And one of the reasons why I was really excited to teach it, because for me, the sky's the limit. I think that Python can do so many fun things and interesting things that anything that you're interested in learning, as long as you're still grasping the core material, I'm fully in support of. Does that answer your question?
Yes.
Awesome. That was probably a lot more words than I needed, but yes, that hopefully answered your question. Okay, so now that you've seen the data pipeline and where we want to be, right, how do we collect the data? And this is where the internet or websites have done a really great job of tricking you into collecting data. And I even tricked you all earlier into giving me feedback on Blackboard. That was really just a data collection scheme. So how do we collect data, and how do we represent it prior to the analysis, or how do we present it back on the back end? And specifically, when you go on something like an Airbnb and you want to just, I guess, poll an area, you want to better understand what types of homes are available, what types of different conditions and filters can you apply. Even if you ultimately don't select a home from that query is simply indicating that there is some local demand for these different things, right? Individuals that like 2 bedrooms also like 2 bathrooms, or individuals that are looking for the dates between, let's say, June 1st and June 14th are also similarly interested in price ranges from $100 a night to $175 a night. So every time you submit a search query, that's new data that goes back to Airbnb. Even if you're not thinking of it as queries, you're simply using the application naturally. And a lot of the data that's being captured in that way, it's called clickstream data. So it's a user interacting with different buttons and features on a website, all of which are usually used for further analysis by an analytical team at that company. Facebook is probably the best example of doing that type of work. Amazon too. Amazon's a good example. Now, once you have this information coming from these clickstream interactions from a user on a website, what's the deliverable, right? So you're going to want to request user details from registration. So you sign up for Airbnb. It's going to ask you some demographic information, how old you are, what's your where do you live, what's your age. I guess I already said that. So gathering that new information, it's going to be able to take that into account every time you make a click in the app, because you've registered with this, I guess, unifying information, and then they can correlate that back to your user activity, creating a persona. What else can we deliver? Where we can deliver an embedded application with analytics, such as Google Analytics is a great example. So you can overlay Google Analytics on most websites, and it can track pretty much anything that you're doing on the website, from where your mouse is hovering to where the most common entry point and exit point are, and it can do a lot more sort of cross application interfacing to better understand your user base. Next up, you can do something like location tracking. So not only how are they using your tool or application, and in this case, Airbnb, but where are they using it from? What's their geolocation? Are most users looking for a place to stay in Manlius coming from, I don't know, North Carolina? So maybe the fact that UNC, Duke, and NC State are all within the same athletic conference as Syracuse, there might be a really large influx of North Carolinians coming from there to go to Syracuse to watch all of the different sports events. And that might be really important because the market there might be a little bit different, and we want to set proper expectations when they come to Syracuse. And then lastly, allowing users to submit feedback, not only about their experiences with the property, but also the property owner. And that gives a new level of feedback that actually builds not a persona around the user per se, but a new persona around the property manager or even the property itself, linking back to the owner. And I think all of those different ways of collecting data go back to what we were looking at earlier with respect to active requests and active properties. So now going on to the next thing, now that we have collected data, we can consider something about automation. Now, again, don't worry, we're probably not going to cover automation in this course per se, but again, the sky's the limit, and there's probably going to be at least 2 sections at the end of the semester, and I think that automation is a really important topic because it can take really awesome projects and turn them into really awesome applications. So automating a data pipeline is something that's near and dear to my heart because it's a lot of the work that I do in my day job. So you may recognize almost all of the elements of this pipeline with the exception of this new thing called user preference or consumer preference. So assume that you've come up with a series of recommendations to the end user, you've served it on the web client, or you've put it on the application. The user is now clicking and interacting with it, and this will now feed back into this thing called consumer preference. Think of this as the aggregate of multiple, user personas. These are more aggregate statistics about different things that users like, dislike, and combinations of queries and the success of recommendations that can then feed back into the model and enhance it. So this is kind of like an example of a machine learning model. And then lastly, you'll notice on the left-hand side, so there was no coincidence that I chose specifically Airbnb because I'm currently obsessed with this new tool, I'm currently obsessed with a tool called Airflow, and it was developed at Airbnb. So while I was reading about this cool tool called Airflow, which is the Python tool, it's a tool that was built in Python, and I think it can stand up most modern programming languages. But what it does is it creates these things called DAGs, which are directed, I cannot think of they're effectively conditional stepwise operations that pull you through data pipelines. And what it does is allows you to monitor and scale different resources in order to accomplish an automated and robust data pipeline. So for me, this is really an interesting application because it takes a lot of the things that we were going to learn in this class and kind of consider them holistically. Yes, directed acrylic graphs. And I thank you for adding that. I could not think of what the A, and it's acyclic, not acrylic. Acrylic is like a paint. Directed acyclic graphs. Cool. Nonetheless, Airbnb came up with Airflow. It's an awesome tool. So for those of you that are interested and want to go above and beyond the coursework, highly recommend checking out Apache Airflow. All right, and then the end of the model, right? So now we've made recommendations and they're going through this machine learning model. So the final notion is like this level of testing and validation. So we've successfully made recommendations to the user or the person that wants to actually publish their home on this platform, like me. And the focus here is that we're sending the user or myself, we're measuring the acceptance rate of the recommended prices. And in modern, I guess we'll call it modern analytics, we often call this the hit rate. So we send a recommendation and the rate at which it is acted on is often called the hit rate. And then if you have the ability to also measure in some other quantitative way the success on a spectrum, you can often call this sort of a notion of a success rate. So for instance, if you can measure the distance among the actual price that someone is willing to buy my property for versus the recommended price, you can sort of determine a level of success above and beyond that recommendation. We can call that either success or a success rate. So here the deliverables will be a specific pricing recommendation in the app or modified pricing over time, especially for new participants. So something I learned is when you post on Airbnb, if you don't have any feedback yet, who's going to want to stay at your place? You might be weird. You might, I don't know, your home might not be very suitable. So they actually allow discounts for the first, I think, 5 people to stay in your home at 20% to cost, so that they'll give you feedback. It's almost like a sort of like a beta test on your home. And then lastly, you can also, another deliverable might be like a rewards program for actually implementing the recommended price point. So if you make our recommendation, we'll maybe cut $5 off the bill, simply because maybe Airbnb truly does know better than you, and they know that if you put it this rate, it'll make them more money above and beyond the promotional reward that they might offer you. So these are different ways that you can test and validate recommendation sets and implement them using these different deliverable types. And this brings me all the way back to the analytics lifecycle that I mentioned earlier, right? So we identified the situation. I want to put my house on Airbnb, but I don't know what to put it for, right? How much do I price it at? So what do? Well, Airbnb does it for me, but they acquire data. They format the data. They analyze the data. They drew inference, and the drawing inferences is the identifying what is the proper price point here. We enact a change, right? We recommend a specific price point, and we even incentivize the utilization of it. Then the user either implements it or doesn't. If they implement it, we have a new baseline for the market rate for your home. If they don't implement it, we can measure the difference of the success had they implemented it versus the success when they didn't implement it. You can kind of find how to tune your model going forward. So for me, this was sort of an example of the end-to-end data analytics lifecycle and why people do modern machine learning and data science and scripting for data analysis. Any questions? This is a great pause point for anyone that has a question or has a thought even. You're welcome to simply interject with ideas or thoughts about the coursework or sort of these more generalized ideas about this type of work. You're also welcome to speak up and just say how excited you are to take this amazing class. Okay. So when I was given the opportunity to teach this class, the initial syllabus indicated that there would be quizzes, and I don't think that quizzes are great. I'm not a fan. I don't think it's especially in a sort of a computer language setting, it's very unlikely that you'd need to do something in a very specific short amount of time without the ability to research or Google. So instead of doing quizzes, I have opted instead to do something called sort of advanced topics for presentation. And specifically, I did this in my other course that I teach, IST652. It gives you all an opportunity to go above and beyond the curriculum, to learn different things in this space, and to present that new knowledge to the class. So what I've done is I did this programmatically, and I assigned everyone a partner. And you can find your partner on Blackboard. And I actually recommend between now and the next session, or I'm sorry, I don't recommend. Between now and the next session, please coordinate with your partner to choose an advanced topic for presentation. More guidelines around the expectations around this are also on Blackboard. If you go to assignments in Blackboard, there's a document about the expectations around the advanced presentation. But what it is Python has a series of extensible libraries that have different purposes or functions. So for instance, I mentioned earlier something called pandas and NumPy. These are two libraries that allow for different types of data analysis and formatting. There are thousands of other open source libraries that are available and actively used by members of the Python community. So what I would highly recommend is take a look at the list of, I think I recommended roughly 30. So there's a wide variety to choose from on Blackboard. But sync up with your partner and pick a presentation topic and post it back to the discussion forum on Blackboard. And what you'll do is you'll learn a little bit about the background about that specific topic, that specific library. You'll have an opportunity to implement the library, and you'll also demonstrate some of the features or functions that that library can do. So an example of the things that I posted in the library are very easy ones. So for those of you that are less familiar with Python, I've also sort of graded them on a level of difficulty from easy to very difficult. So on the easier end are things like OS. OS is a library that allows you to interface with your folder structure by simply using path logic and searching. So if you wanted to say, load the file that lives in this folder, you would be able to use the OS library to navigate your folder structure, sort of like a tree, the same way that it's designed when you interface in Finder on Mac or in the folders on Windows. Now, on the more extreme end, there are advanced machine learning libraries that you're also welcome to give it a shot. Now, I'm not going to grade based on the level of difficulty. It's simply whether or not you can achieve the outcomes designed in the presentation. So please choose wisely. But for this class, starting in lecture week 3, there's going to be at least one presentation every week for the remainder of the session. Remainder of the semester. So everyone will get an opportunity to present in front of the class with a partner on a very, I guess, unorthodox manner of analysis. And I say unorthodox because it really just doesn't fall into the typical curriculum for this class. But I think it'll give you a great opportunity to learn a little bit more of the other things that are going on with respect to analysis in Python. And hopefully it'll give you an opportunity to work closely with a partner and get to know them a little bit better. Any questions about advanced topics for presentations in this course?
Yes, Professor Nichols, I have one. The partner that we were assigned for the advanced presentation, that's also the same person that we're going to work on the final project with, right?
That is not. So
okay.
The final project will be up to your discretion. You can work on it alone, or you can work on it up to 2 other individuals. So you can have a team of 1, 2, or 3. And that is your choice. But for the advanced presentation, you were randomly assigned a partner. Any other questions? Okay. And to kick it off, I will give the first advanced presentation during the next lecture in 2 weeks. So over the next 2 weeks, I will prepare a lecture. It will be between 6 and 8 minutes, and I will present it to you so that you have a sort of an expectation around what goes on during the presentation. In addition, this course will have a final project. Now, the final project has 2 checkpoints. It has a project proposal, which I believe on the syllabus is due the first or second week of March. And the idea here is that you will have picked a topic that you're interested in, and you'll also have identified some data sets that you think will help solve the problem. And then the final deliverable will be a sort of like a report of the problem that you were trying to solve, a description of how you approached the problem, acquired the data, the considerations you put around formatting and cleaning the data, and the analysis that drew you to a result. And then you're also going to submit the code. So you'll notice here, and this is probably the first time you're seeing it now, anytime that you submit code in this course, you can submit it in one of two ways. You can either submit it as a .py file, that's short for Python. It's the normal Python file, nothing special. Or you can submit it as an IPyNB, and this stands for IPython Notebook. And we'll demonstrate this a little bit later today, but it's a very common framework for data analysis in Python specifically. More details about the final project are already on Blackboard. You can see the requirements both for the project proposal and the final project deliverable. But you have a little bit of time to think about that. For the project deliverable, you have about for the project proposal, you have about a month and a half to select a topic and find some data sets. And then for the final project, you obviously have until the end of the semester in order to execute against that. Now, if you have multiple people working on the project, I expect that your project, if you have 3 people working on it, is 3 times the amount of work as a single person's project. So there is a level of expectations around partnering. So please keep that in mind as well. Any questions about the final at a high level? We don't necessarily have to get into exactly what that looks like now, but does anybody have a question so far? Okay, very good. How will you be assessed in this course? So we're going to have 6 semi-weekly labs. Not every week there will be a lab. For instance, there will not be any assignments between this lecture and the next lecture in 2 weeks. We have a question, one moment. Are we going to have a presentation for the final project? As it stands, no. There will be no presentation for the final project. But we can always think about things like additional credit where you think that your presentation will somehow drive the value of your presentation upwards. But we will have that discussion later in the semester. Any other questions? All right. Oh no. Go back. There we go. Okay. Like I was saying, we're going to have 6 semi-weekly labs. These will probably be somewhat easy. I shouldn't say that. These will be somewhat more feasible than the mini project and the final report. The weekly labs should take roughly 1.5 to 2 hours each. The mini projects will be more extensive. They'll require a lot more time and effort. There will be 2 of those throughout the semester. And then lastly, there'll be the final report and final proposals, in addition to the advanced presentation. Lastly, I like a classroom that's highly participant. It has a high level of participation. This would include helping dictate new solutions or code examples, answering and raising your hand during class. But for those of you that are less comfortable speaking outwardly in public, I think we're also going to do some discussion forums on Blackboard. These are not mandatory. These are completely optional, but just keep in mind that this is a professional environment, so please keep your answers professional, and valuable feedback on these discussion forums will also be considered during the class participation grade. Any additional questions about the assessment criteria for this class? Okay. Grading policy. So generally speaking, grades should be non-negotiable. I'm going to design the rubric to be very black and white, but in the event that you ever find an error on the grading, please let the TA, her name is Nishita, and just simply CC me for reevaluation within 1 week after the grade is delivered to you. So I don't want the end of the semester to come around and anyone asking how we can change grades. Generally speaking, grades will be fairly straightforward, and if there are any issues with them, please let me know immediately so that we can resolve them. Otherwise, the way that we are going to divide out the grades will be as follows. An A will be 95 to 100 points. And just keep in mind that every assignment will have a point value, and the total points associated with all of the, material throughout the semester will accumulate to 100. So for instance, if I submit a weekly lab, that lab will be worth, for instance, 5 points. So if you get 4 out of 5 and you get complete credit on everything else, you will end the class with a 99 out of 100. This class, generally speaking, will not be curved. So ideally, you should be able to track your progress as we move forward in the semester by simply accumulating the grades that you receive on your assignments. Does anyone have any questions about the way that this class is evaluated and graded? Okay. How to use Blackboard for this course. Blackboard, arguably not the sexiest piece of technology for sure, but it does have its usefulness. So specifically, the first thing that I would ask you to do is find your group on Blackboard. Once you've found your group, please communicate with the other person. There should be an ability to communicate with them over Blackboard via email. So please set up that communication channel and try to start thinking about the advanced course topic. Specifically, I believe that in the syllabus, there is the week for which you're going to present. So if you're less familiar with Python coming into this course, which many of you probably are, I would highly recommend you choose an easier package than if you had one that's later in the semester. Now, obviously, the first couple of weeks, you're more than welcome to email me if you're struggling implementing the advanced topic, and I'm happy to address that with you. Okay. Each lecture will start with the advanced presentation. It's the first thing we're going to do in every lecture. Next up, we're going to talk about different, programming concepts and different data analysis pipelines that we design. And there's also going to be in-class exercises. The in-class exercises will be a way for me to more or less take attendance. They will not be graded. So anytime I ask you to submit anything on Blackboard, it will not be graded. It's more of sort of binary. Did you submit something or did you not? So by the way, let me actually repost it. But in the, where is it? The chat, there's a link to all of the discussion forums. If you can just simply at least answer the one regarding your major, then I will use that as a way to take attendance for today's lecture. If anyone has any difficulty doing that, just let me know, and I will just write you in as present today. Okay. All right. Ideally, I should be able to always save hopefully 10 to 15 minutes at the end of each class so that you can begin a lab, so that you can review it and ask any questions about the material or any of the questions ahead of time. Each lab will be due Saturday at midnight following Monday's lecture. So if you have a Monday lecture and you have a lab for that week, it's due at Saturday at midnight. And the reason that it's due on Saturday is so that I can hopefully have an opportunity to grade it on Sunday for class on Monday. In an ideal world, I give you frequent feedback about the progress and the way that you're using the techniques and the knowledge that you're gaining in this course, so that we can correct and sort of move forward in the material, and we don't get too hung up on some of the earlier implementations. So I understand that Saturday can be a difficult time for a lot of people to work on homework and labs and things like that. So I do highly recommend that if you're struggling in the course at all, let me know and we can set up additional office hours, or you can work with our TA. I also I realize now that I'm swapping between TA and FA. They mean the same thing. TA is teaching assistant, FA is faculty assistant. They mean the same thing. So if you see FA, it's the same as TA. So Nishita is not on campus yet, but once she is, we can work with her to find the right time for an additional FA office hour. And I don't think I put it on Blackboard yet, but we can have a discussion regarding the best time for that, for the class. Any questions about how to use Blackboard? Does anybody have an issue with the way that we anticipate using Blackboard? Generally speaking, I'm going to post the assignments in the assignment section. I will also link to them each lecture, and we'll talk about the way to properly submit material for this course. Now, this is a takeaway for all of you. Between now and next class, these are the expected readings that I will assume you will all have done by the time we start next class. And it's the first 5 chapters of the Python for Everyone online book. 5 chapters, I promise you, you could probably read all of these in less than an hour. Each chapter is probably about 5 pages long, 6 pages long. And I highly recommend, if you have the capacity for it, to try and code some of the examples or similar data structures that are defined in the first 5 chapters. It'll give you an opportunity to put fingers to keyboard and really better understand what the author is talking about when we go through things like conditional functions or iterables. So again, please read these first 5 chapters before class next time, and if possible, do your best to implement some of them on your own. Okay, so why are we taking this class? Because scripting for data analysis is a lot of fun. You're going to learn some really interesting things, and it's going to be a great opportunity to become more affiliated with modern data analytical techniques, as well as sort of modern data structure. So you're going to have opportunities to learn about NoSQL databases, unstructured logs, semi-structured HTML, and also the ability to use Python, which is, I think, amazing. Python just blows me away. What is this course not about? I want to make sure it's not about data science. So I know that I said data science a lot today, and I probably won't say it nearly as much throughout the rest of the semester, but it's sort of like building the foundations for data science, more or less. But it's ultimately not about machine learning. It's not about implementing statistics. It's simply about collecting, formatting, cleaning, and preparing data for more sophisticated analysis, or serving it up on a website, or simply learning a little bit more about the world. And what are our learning goals, and how do we achieve them? We achieve them through reading the text first and foremost. Both textbooks that we're going to use, Python for Everyone and Python for Data Analysis, are enjoyable reads. I promise you, they're not your typical textbooks. Additionally, I think that coming to class and working on the different accessible materials are really important. Anybody that took my earlier class last semester on database structure and design will attest. I do try to keep classes pretty interesting. I know that today's format's probably a little strange, and maybe it's not going to come across quite as, I guess, energetically, but definitely when I'm in class, I'm going to try to keep it fun. I'm going to keep it interesting, and hopefully you'll learn a lot about Python, data analysis, data structures, and I can throw in some anecdotes here and there. And then lastly, using Blackboard, right? Use Blackboard efficiently. Use it for a communications channel. I'll try to post interesting materials in the discussions. If anyone has ventured into the discussion section of Blackboard already, I posted a couple of interesting videos that I've watched before, I posted a link to a podcast that I listen to all the time. It's called Talk Python to Me. And hopefully, not hopefully, I will continue throughout the semester to post other interesting things related to the material in this course, so that you can all stay contemporary with what's going on, not just at Syracuse, but also in the real world of data analysis. So, as a reminder, the action items for the next 2 weeks. We haven't touched on this yet, but you're going to need to install Anaconda on your personal computer, and I'm going to describe what that means. But it is also available on the labs. So I really would love if you all had it on your personal computers, but again, it is available at SU. And the URL to do this is in the syllabus. Please, by next class, finish the offline reading. I will ask that each group finalizes their advanced topic by next Monday. So please start that conversation now. You have a week to decide. And again, if you're less familiar with Python, if you're less familiar with Python and you have a relatively early presentation with respect to the progression of the semester, I do recommend you choose an easier topic. But again, I am willing to help anyone that is struggling. And then please update your topic in Blackboard on the discussion forum. That way, we don't have two groups doing the same topic, and I don't present a topic in 2 weeks that has already been chosen. And then lastly, just start to think about interesting problems that you'd like to learn more about. Pretty much any problem that you can think of, if you don't know about an available data set, I can work with you personally to try to figure one out. Whether that's using, I don't know, proxies for different resources. So if you want to learn more about a particular industry, a good way is to learn a little bit more about the open jobs in that industry. And then you can develop an algorithm that pulls data from Indeed by, I guess, hacking the search criteria and then pulling down the results via an iterable web scraper. Or, for instance, if you want to learn more about foreign politics in a particular country, we can, I guess, just try to find different data sets from UNICEF and see if there are different, I guess, humanitarian crises or different humanitarian interactions that we can use as a proxy for particular politics in a country. There is a question. Yes, regarding attendance today, if you can just post in the major discussion forum, that will give me an opportunity to evaluate who was in attendance today. Because as I mentioned, the first week of class, as a professor, I have the opportunity to review anyone that was not in attendance and determine whether or not they're suitable for this class. And it's mostly because there's a very, very long waiting list for other individuals to take this class. Okay, so these are the action items for the next 2 weeks. So this is sort of your North Star for what you should be kind of working on outside of class. And this is just the appendix. We don't have to go through the other 2 slides, but it is posted to Blackboard under Materials Lecture 1. So we've been at it for about an hour and a half, and I'm going to take about a 5-minute break. So in the meantime, relax, loosen up. I'm also going to turn a light on. I didn't realize how dark it was. Okay. So questions about Anaconda. Anaconda 3.7, please. all Python in this class